Hi friends, this video we are going to solve this problem. So this is the question asked in the GATE 2024, the Mechanical Engineering Department question paper. So this is a 2-mark question. Okay. So let f of z be an analytic function if the real part of f of z is cos h times cos y. The imaginary part of f of z is 0 for y equal to 0. Then what is the f of z? That is my question. So I have to find what is the f of z. So the given is u of x comma y is the given, that is cos h x times cos y, that is the given. So now I am going to use them. So it is so I can use only the CR equation or Milne-Thomson method, but they give the additional condition the imaginary part of f of z is 0 whenever y equal to 0. So to find the constant c, they given the imaginary, that on condition they given. So that is why we are going to use CR equation is the best option. So what is the CR equation? CR equation is du by dx equal to dv by dy, then du by dy equal to minus dv by dx. So this implies you take derivative with respect to x. So du by dx, cos h x you take derivative, what will get? You will get the sin h x times cos y. So you must know that d by dx of cos h x equal to sin h x, and d by dx of sin h x is cos h x. So it's a hyperbolic function, not the trigonometric function. Please remember. Okay. Cos h x, if you take derivative with respect to x, you will get the sin h x, cos y is same thing. This is equal to our dv by dy. So this is implies v of x comma y. If you are going to integrate with respect to y, so what will get? Sin h x is treated as a constant. Cos y, if you are integrate, you will get the sin y. So sin h x times sin y plus some phi of x, that is v. Got it? Correct? Now I am going to, what is the phi of x I want to determine. So how I can take? So du by dy, you can take derivative. So cos h x, if you take differentiate, you will get the minus sin y. This is equal to minus dv by dx. So this implies dv by dx equal to cos h x times sin y, because minus time I multiplied. So now from here, using this one, I am take the derivative with respect to x, that we will get it as dv by dx. So this is, I am going to take partial derivative with respect to x. dv by dx equal to sin y I treated as a constant. So sin h x, if you take differentiate, you will get it as a cos h x. Cos h x times sin y plus phi prime of x. Now you compare, this is you treated as a, this is treated as a b. So this implies v of x comma y equal to cos h x times sin y, phi prime of x equal to 0, implies phi of x is some constant k. So to determine the k also they given the imaginary part of f of z is 0 for y equal to 0. So whenever v of x comma 0 equal to cos h x times sin 0 plus k. So the imaginary part is 0 they given. So this implies k equal to 0. So now I want to, so I make that k equal to 0. Now I want to find f of z. F of z equal to u of x comma y, that is cos hx times sin cos y plus I times v of x comma y is cos hx times sin y. Okay. Now I want to, that is, now if you are looking the result, everything in terms of x, I, y, this is not there, z will be there. So in the function of z is more convenient one for us. So that is the result, very simple. Okay, you taken as f of z is equal to, this is the formula, u of z comma 0 plus I times v of z comma 0. That result you can use it. This is the very nice result to convert the function in terms of z. Okay, what is the f of z? U of z comma 0 is cos hz, cos y is 0 means 1 plus I times cos hz, so cos hz times sin 0 is 0, so this whole term is 0, so that's f of z equal to cos hz only. Okay, so using this result we get the answer is cos hz. So to find the function f of z is, please use this formula. This formula is very simple. Otherwise, you have to evaluate what is the x equal to z plus z bar divided by 2. That is too tedious. So in the type of gate type examination, use this formula, gives the very efficient way of the answer. I hope you can understand. Thank you for watching this video.